So today we're going to go over some of the common questions with regards to spring soil sampling versus fall soil sampling with our field rep, Jim Grilliot, and our account manager on the agronomy side, Brendan Juarez. So I'm going to start with the question here. Is there a certain test package that you recommend and why, as far as this time of year and sampling my soil?
Yeah, Megan, what I generally recommend is if the field or farm is new to the grower, I would prefer to have an S3C run on that. That is our most comprehensive standard package, soil test package. And the reason for that is we want to be able to take a look at everything. Moving forward, we can eliminate some things such as sodium soluble salts, perhaps. Maybe there's no need for nitrate and some or all of the micronutrients, but we want to rule those out. And so initially I want to take a look at those. However, if it's a field or a farm that is very familiar, there are a lot of options, starting with our most basic S1A. Of course, we can add to that possibly sulfur and zinc, or sulfur along with all the micronutrients. But that is really up to the grower, the retailer, the consultant, and there are a lot of choices there. And then also individual analysis above and beyond a soil test package.
Yeah, Jim, I agree with you there too. And, especially when we get into grid sampling situations, we most commonly see the S1A, ran on those, but also, depending on what types of micronutrients they may have for placement there, whether it be the S5, which includes our sulfur and zinc, or all the way to our S3 package that has our full micronutrient package, just depending on, what that client is planning on applying, is really what dictates which package you go with.
Yeah, absolutely. The way we're set up, we can make we can put together a custom package. We want to be able to accommodate our clients and allow them to do what they want.
If I am curious about nitrogen issues specifically, is there a different test that you recommend for this purpose, and why?
Well, how I would answer that is, so on our basic soil test package or packages, you can request nitrate as a standard. But understand it is just nitrate. And if there is a need for ammonium nitrogen, that would be an add-on test, an individual test. And there would be situations where we would recommend adding ammonium nitrogen to that along with that test. And that scenario would be possibly in the spring or late spring, where perhaps it was a cool, wet, early spring, and going into the mid part of spring, and crop growth was slow, and then eventually we get a warm up, and then plant growth just takes off. It's tremendous, and there may be a need for understanding the two forms of nitrogen that's in that soil, and so you want to understand what nitrogen is out there that has not converted to nitrate, and that would be ammonium. So that would be a scenario where I would recommend requesting that add-on.
Okay, so with regards to adding lime, how long would it take usually to see changes from adding lime? And should I sample differently then after I add lime?
So as far as when we'll see an effect on lime, that's truly dependent on what the quality of lime is. The higher the quality, the easier the incorporation it can be. And so we can start seeing effect fairly quickly throughout that season or come the next season. The biggest thing that comes into play here is weather itself. So if we were to sample right after a lime application, we would definitely see the calcium raise. However, we may not see the pH differ for some time. And that's ultimately due to the amount of moisture that it takes or it needs to carry out specific chemical reactions to raise that pH. And so when you run into those situations where we may see a higher calcium, but the pH hasn't moved, that essentially would mean that we haven't seen those chemical reactions take place to move that pH. Jim, do you have anything to add to that one?
I always like to add in a real life scenario. When I was in ag retail I dealt with a couple different lime products. One being an average, roughly a 60% effective calcium carbonate equivalent, and the other an 80%. Both worked well as far as changing that pH, the difference being how long it took, and that's really what this question is about. But generally, a 50-60% ECCE lime, I wouldn't expect to see that entire change for over a year. However, that 80%, I was noticing changes, and I took samples just for this reason during that time, but I would see a complete change in 6 months. So it differs with the quality of the lime. And it's not to say that a lesser quality lime, a lime that isn't crushed as fine, is not going to work. It certainly will. It's going to take longer. So understand that. And again, the point about moisture is so key. Without that, it will take longer.
So for the both of you, how do you recommend going about creating the correct zones for zone soil sampling in row crops?
For me, without having any historical information, the only thing that I can go with is soil texture. But I don't necessarily like that method. What I like to do is start with grids, and that could be multiple different size grids, and that would be up to the grower or retailer. But gridding, in my opinion, allows you to look at smaller areas, develop some yield data on those areas, and eventually you can decide on some zones. But ultimately, in my mind, I mean, yield data is where you're going to develop those zones. Because if we just strictly look at soil texture, you can raise a tremendous crop on a sandy loam as you could on a clay loam. There are pros and cons about both soil textures, different management. So I don't want to solely focus on soil texture in developing a zone. Again, ultimately, I want it to be based on yield data. What can that piece of ground, what can that farm yield?
Yeah, I agree with you, Jim. Especially when we're looking at trying to find that defining line in a smaller area, the grid sampling approach is going to give us the best results on how to handle specific acres. And really, in true practice, not all yield is created equal, not all soil is created equal. And when we think of a good yielding number on one farm may not be the best yielding on the next. And so we always have to take that into consideration. Now, with zone sampling itself, and if someone is really wanting to push forward from that approach, whether it be equipment capabilities or preference, the biggest thing that I take into account too, just like Jim said, is texture. And the way we can get that is looking at USDA soil series maps. And so that's really going to tell us where those soil series are, where they lie. Now, granted, they're many years old. They're still really accurate as far as the technology they had at the time and depicting where those differentiating zones could be. So I always look at soil series, and I also take into account the topography itself. So if we have a gradual hill or even a steep slope, we definitely want to segregate that out from a bottom. And so when these zones are being created, I always try to think in a sense of anywhere from 5 to 10 acres, no more than that, essentially because we're not accounting for as much variability. And so with that being said, I usually look between the topography and the soil series maps to at least make my best educated decision on how to lay out those zone samples.
Does the quality of the sample in terms of collection of depth, complete core, and location of cores taken affect the results in the lab analysis?
All right, yeah. So as far as the laboratory itself, we're only as good as the quality of core that's taken out in the field. So from a data standpoint, the only thing that essentially changes based on depth for us would be if you're requesting a nitrate analysis. And what that does to change it is ultimately the calculation for total pounds of nitrate nitrogen per acre. As far as the readings itself, whether it be phosphorus, potassium, calcium, magnesium, those don't change based on the depth on how we do our readings. However, just keep in mind as primarily the most saturated profile with nutrients would be that top 2 to 4 inches. If you're doing bands, we may have lesser nutrients on the top, but more, say, down to that 4 to 6 plus inch. And so we can see those nutrient saturations throughout that profile. And so we can get some dilution essentially from other profiles that may not be as nutrient rich. So the numbers can change based on the depth taken for each core. And that's why it's really important to make sure that you're calibrated when taking those cores, examining those every time you take those out of the ground. If you put that soil probe down to 6 inches, you should expect to see a core that is 6 inches. If we have cores that are 2 to 3 inches, maybe 4 inches, even though we put the probe down 6 inches, that's telling us that we may not be getting the full profile, and we may be running into specific soils that may be compressed in that core. So once again, it's ultimately, from a lab standpoint, we're only as good as the sample that's taken.
Since it is spring soil sampling time, does the time of year we take samples matter? And as far as spring versus fall conditions, is it smart to take it in spring and fall?
Most important thing to understand about when you sample is what works best for you. It doesn't matter whether it's fall or spring. It's what works best and suits your needs. There are certainly situations where if you normally sample in the fall and conditions are such that you can't get a good core, it should be put off until spring, or at least when you do have moisture. Because depth of sample, as stated before, is so important, and you want to make sure that depth is consistent throughout the fields and throughout the sample points. So again, things like conditions of that soil, if it's too dry, if it's too wet, if it's no-till, if it's tilled. For instance, a freshly tilled soil is going to be difficult to get a good core, so waiting until you have moisture to kind of set that soil down and firm it up a bit so that you can get a good 6-inch core, whatever depth you pull. So again, time of year isn't as important as just being able to get a good core. Now, ideally, we want to stay consistent. If you sample in the fall, we want to continue to sample in the fall. If you sample in the spring, let's be consistent about it. But can't be more important than taking a good sample. So keep that in mind.
Will dead weeds and plant residue on the top of the soil, when brought in with the soil sample, affect my testing results?
Yeah, that's a great question. So when we do our method for organic matter specifically, so that's a loss on ignition method. And so what we essentially do is we first dry it down to 0% moisture, and from there we ash that soil sample at 800 degrees, roughly Fahrenheit. And so with that being said, a lot of the organic residue, from previous crops and whatnot that could be within that sample may not get burnt off, essentially. So with that loss on ignition method, we're looking at measuring what is the percent organic matter within that soil solution, rather than inerts that wouldn't be necessarily in that soil solution at that time. Now, we can see, depending on the stage of degradation on that organic material, we can see that skew results because some of that's partially decayed. So when we ash that at a higher temperature, we may get some of that accounted for within that final weight once we weigh that sample after it's been ashed. And that can also have effect, especially on our nutrient extractions, simply because that organic material floats to the top of the extractant that we're using. And so we may see two things. Sometimes we may see more nutrients being taken up and pulled from that organic matter material, partially to where it's not giving a true representation of just the soil itself. Or flip side, we may see lesser nutrients because that organic matter is pulling up soil along with it to the top of that extractant. And so we can see both ways on that. So it definitely can skew results. So when you're sampling, we always recommend to make sure that the residue is pushed aside and that you're getting as much soil as possible, within that sample. We can't help with small root systems. That's definitely going to happen. But if we get the bigger residues like husks or pods or whatnot through that, that's where we can start seeing some of those differential results. But once again, to just reiterate, as far as reading the organic matter percentage, it can have a slight effect when we have that loose organic matter residue that isn't yet fully decomposed or partially decomposed. So we can definitely see that.
So when gathering my soil samples, how important is it to collect that full two cups of soil per sample?
In the lab, it's very important. We're going to need a certain amount of that sample to do a number of analysis. And also we're going to save that soil for a certain amount of time after the analysis for potential of add-ons or the possibility of needing to rerun a sample or samples. And so it's very important to have that soil bag filled to the red line every time so that we have enough not only for the initial analysis, but for the possibility of needing to rerun something. If there are any specific questions, would be glad to discuss that if anybody is interested.